Hello everyone and welcome back. In this video we're going to talk about the one sample t-test, which is used to test hypotheses about a population mean. Now the assumptions and conditions for the one sample t-test are the same as the one sample t-interval. Recall that we have the independence assumption, which is checked with the randomization condition, and we also have the normal population assumption, which is checked with the nearly normal condition. We test the hypothesis where mu equals mu naught, and we calculate the test statistic by standardizing our sample mean. The sampling distribution model we will use is the t-distribution with n-1 degrees of freedom, and we use this model to find the p-value. As before, the calculation of the p-value will depend on the test type. So let's take a look at an example. Suppose that a fast food restaurant manager wants to find out whether the soft drinks they sell differ in volume from the advertised 470 milliliters. A random sample of 10 independently chosen drinks produced a mean of 488 milliliters with a standard deviation of 12 milliliters. Assume that the distribution of volumes in the population is normal. Carry out the appropriate hypothesis test at a significance level of 1%. So let's first identify the hypotheses for the test. So we want to test whether the volume of the soft drinks differ from the advertised 470 milliliters. So this tells us that the mean is equal to 470, and the alternative is that mu does not equal 470. So now let's check the assumptions and conditions required for the test. So we have the independence assumption. And so the volume of one drink should not affect the volumes of other drinks. So we look for randomization. We're given that the drinks were chosen independently. And the other assumption is the normal population assumption. And so we're given that we assume the distribution of volumes in the population is normal. And since we're dealing with a small sample size, then this assumption needs to be made in order for the results to be valid. And this was given to us in our problem. So now let's calculate the test statistic. So we're given that the sample average is 488 milliliters. The standard deviation is 12 milliliters, and we have a sample of 10 drinks. The standard error is the sample standard deviation over the square root of the sample size. So we take 12 and divide it by the root of 10, and this will be approximately 3.7947. And now we can calculate our test statistic. So we have 488 minus 470 divided by 3.7947, which is 4.743, rounding to 3 decimal places. And now we can calculate the p-value. Since we're looking at a two-tailed test, then we want the area of both tails. And because of symmetry, we can find the area of one tail and then double that value. So we can take 2 times the area to the right of 4.743. And we also need the number of degrees of freedom, which is n minus 1. So 10 minus 1, which gives us 9 degrees of freedom. So now we're going to locate our test statistic of 4.743 using our t-table. With 9 degrees of freedom, we see that 4.743 falls to the right of the table. And so the closest value is 4.297. So now let's write down the area the table is giving us. So the area to the right of 4.297 is 0.001. So if the area to the right of 4.297 is 0.001, then this tells us that the area to the right of 4.743 will be less than 0.001. Now our p-value will be double this area. So if we multiply both sides of the inequality by 2, we get that 2 times the area to the right of 4.743 will be less than 2 times 0.001, which is 0.002. And so the p-value is smaller than 0.002, or as an interval, the p-value is between 0 and 0.002. Now let's compare this to the significance level. Now the p-value is smaller than alpha, which is 0.01. So we reject the null hypothesis. And this tells us that there is sufficient evidence to conclude that the mean volume of soft drinks differs from 470 milliliters. And so this concludes our lesson for this video. In the next video, we will talk about the relationship between confidence intervals and hypothesis tests, and I'll see you then.